Hello student, our today topic is CFT. The full form CFT is crystal field theory. This theory was given by Hans Bethe. Student Hans Bethe in 1929. The main postulates of this theory, actually this theory CFT is a bonding model that explains many important properties of transition metal complexes like stability, like structure, magnetism and stability. The main feature and the main postulates of this theory are the bonding between, girls and boys, bonding between CMA and ligands are purely electrostatic, meaning these are the ionic, purely statics. Ligands are considered as a point charge in case of anion, girls and boys, in case of anion, meaning negative ion, right? And dipole in case of neutral ligands, right? The 5d orbitals of an isolated gaseous metals or ions have the same energy or also called degenerate orbitals, right? Now, however, in a complex, due to asymmetrical negative field of ligands, the d orbitals are no more degenerate. Girls and boys, no more degenerate and split into two set of orbitals. There are two set of orbitals. First, EZ and T2Z. In an octahedral environment, the dx square and dz square orbitals which point toward the axis, along the axis, the direction of the ligands will experience more repulsion, and will be raised in energy. That's why they have higher energy compared to very average energy level. The dxy and dyz and dxz, another three d orbitals which are directed between the axis, will be lowered in energy, called T2G set, right? Next, the splitting of degenerate orbitals due to presence of ligands in definite geometry is known as crystal field splitting, and the difference of energy between two sets of degenerate orbitals as a result of crystal splitting is known as CFSC. The full form of CFSC is crystal field stabilizing energy, or also denoted by delta O. The O subscript stands for octahedral, right? It is found that EZ orbitals are 3 by delta O above the average energy, and the T2G orbitals are 2 by 5 delta O below the average energy. Look at this energy level diagram. In this energy diagram, we can learn easily the d orbitals. There are 5 d orbitals of the free ions or metals. The average energy, also called degenerates, but in the presence of ligands, there are no further degenerate and split into two sets. First, EZ and T2Z. The EZ field, actually they are along the axis and feel the more repulsion and have the higher energy level, called dx square, y square, and both set called EZ. They are the 3 by 5, the very center or average energy, above the average energy, and 3 by 5 delta O is the below average energy. The dxy, dyz and xz, they are the between the axis and they feel the less repulsion, and that's why they have lower energy, right? And next, the most important things in this theory, that if delta O, meaning CFSC, crystal field stabilizing energy, is less than pairing energy, if delta O is less than pairing energy, then the fourth electron filling in T2G3 and EZ1, and this appear due to weak field ligands, and also complexes are called high spin complexes, right? In the next case, if delta O meaning CFSC is more than pairing energy, then the configuration will be T2G4 EZ0, and the complexes of ligands are also known as the strong field ligands and have the low spin complexes. The magnitude of delta O meaning CFSE depend upon the field produced by the ligands and the change on the metal ions and charge on the metal ions, right? The arrangement of the ligands in a series in order to increasing field strength is called spectrochemical series. For example, I minus have a lower crystal field strength compared to Br. When we arrange these ligands in ascending order of their splitting or field strength, we called spectrochemical series. That's it, student. And now again I am repeating something, right? Yes, student. If you have D4 electrons, the filling of 4 electrons 1, 2, 3, then 4, 1, 2, 3, then 4. If the ligands are strong field, then pairing will be possible. It's meaning delta O is more than P. So first electron goes in lower energy, second, third, and fourth. The pairing is possible, and the electron T2Z4. If delta O is less than P, then the fourth one electron goes on dx square and y square, right? Thank you.